Okay, we've been working a lot in class with different rules for triangles and rectangles and parallelograms. We've also have been working on how to find areas of shapes when you can't use the rule or when you're asked to explain a rule. So I'm going to do two problems that we've talked about in class to try to help you remember the ideas. So this first problem is this problem with the triangle here. And we're going to figure out the area of the red triangle without using the triangle rule. And the reason we're going to do that is there will be times where you have shapes that don't have a rule and you have to think creatively. And this is a good place to start. So things that we do know is that the area of a rectangle is length times width. So I can take this triangle and I can surround it, and I'm going to do that with a rectangle, and I'll make it a colored rectangle so we can talk about the different pieces. So if I take this rectangle here and make it sort of see-through, this whole rectangle is, if you do some counting, 1, 2, 3, 4, 5, 6, 7 units by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the area of that whole rectangle is a 7 by 12. I'm going to just draw a little picture of that, of my thinking. And 7 times 12 is 84. So I know that the area of the rectangle is 84 square units. But I also know that the top part of that rectangle is a triangle. So to get you to see that piece, I'm going to make an overlay here. And this triangle here, I think you guys can see, if I clone it and rotate it, together that yellow triangle is exactly half of the rectangle. So I'm going to cut that. So the yellow rectangle up here is half of 84. 84 divided by 2, which is 42 square units. So if I want the red rectangle or triangle, I have to subtract, do some subtraction, because I know that the bottom part of the figure, if I trace that with a bright yellow, kind of a fat bright yellow, this part here, this triangle here, that's kind of hard to see. Let's make that a different color. That black triangle right here, this is also 42 units. So if I make one more triangle and fill it up here, right here, from here to here to here to there, this, if you look through here, you can see that this triangle is 3 units by 7 units. And it doesn't need to be see-through if you know the dimensions to find the area of the triangle, because the area of the triangle, that little 7 by 3 triangle, the area of that triangle is 3 times 7 divided by 2, which is 21 divided by 2, or 10.5. So out here, I know this piece is 10.5. So to find the area of the red triangle, I know it's less than 42 because the black triangle is 42. So I'm going to take 42 and I'm going to subtract out the 10.5 because this is 42, this part right here. This is 42. I might have said 45 by accident. And I'm going to subtract out this 10.5. And then I'll be left with the red area. So together, this, when I subtract that out, 10.5 taken from 42 is 31.5, and its area, so we say square units. This was 10.5. We figured that out from there. We can check our work because the three pieces should add to the 84. So 10.5 plus 31.5 plus 42 with 0.0 there. 5 plus 5 is 10, carry the 1. 1 plus 2, 1 plus 1 plus 2 is 4. And 1 plus 3 plus 4 is 8. 84 square units. So today in class we did a new problem, which you see here, problem number 3. And this also requires some creative thinking. I'm going to do this problem 2 different ways. We did at least one way in your class, and some of you, we might have done it 2 ways depending on the class. The most common way that students chose was to divide into pieces because we now know how to find the area of triangles and rectangles and parallelograms. Most students started with those 3 pieces, but when you look on the far right, you realize the piece over here is neither a triangle nor a rectangle or a parallelogram, so you have to do one more division of shape and make it into shapes like that. So there's 4 pieces, and I'm going to label them area 1, area 2, area 3, and area 4. All right, so if you look at area 1, it's a triangle. So we know the rule for a triangle is base times height divided by 2. So we are going to identify the base and the height. So the base is 2, and the height is 3 because this height matches that length. And we always look for the square angle, and we drew that line in here to be a square angle. So that's why we know we can use those 2 numbers. So the base is 2, and the height is 3. And I'm going to divide that by 2. So that's 6 divided by 2, which is 3 square units, just for that triangle. Let's put this up a little bit. The next part, area 2, is just a rectangle. And actually, when you look at the base and the height of the rectangle, the base is 3, and the height is also 3. So it's not just a rectangle, but it's a square. So for area 2, that's easier. We're just going to do base times height. That's 3 times 3. So that's 9 square units. I'm dropping these all down here because we're going to add all the areas together to get the total area of this complex shape. For area 3, we have another rectangle. So we're going to do base times height again. But now the base, whoops, sorry about that. The base is also 2. And the height, you can see here from the numbers on the side, is 2. So 2 times 2 is 4. So now we have 3 pieces. Make that red so it's easier to see that it fits in here. And then this area 4 is a triangle, and the square angle's right here. And we know this is 2, and we know this we have to figure out. But if this is 2 units, and the whole height is 3 units, if this is 2 units, then that leftover piece has to be 1 unit, because these 2 together have to make 3 units. So the base times the height there for the triangle is 2 times 1 divided by 2, which is just 2 divided by 2. Which is equal to 1. So we're going to add that in. Let's move that up a little bit. We're going to add that in as our 4th piece. We'll make that 1 right here. So to get the area, we have all of these pieces added together. So I'm going to add all these pieces together. And we did this in class. And when we add all that together, 3 plus 9 is 12, plus 4 more is 16, plus 1 more is 17. So we say it's 17 centimeters squared. So the final answer is 17 centimeters squared. So most people in class did that. But because the other day we worked on this type of problem where you can surround with the rectangle and subtract out, I want you to look at this problem one more time and see if you can see that there might be an easier way. In other words, if I take this rectangle and surround this shape with a rectangle, that green rectangle, I know that I can figure out the area of a rectangle. And when I look at this picture, I can add all of these numbers here. 2 plus 3 plus 2 is 7 centimeters. So I can take that picture and just do the big rectangle, which is 3 by 7, which is 21 centimeters squared, and subtract out this triangle right here. So if you think of that triangle, I'm going to just rotate it. See, it has a base of 2 and a height of 3. So I can subtract that out. I'll draw a little picture of what I'm doing here. So I'm going to subtract out that triangle, which is 2 by 3. So 2 times 3 divided by 2, because it's a triangle, is 6 divided by 2, which is 3 units. So I'm taking the 21 units from the rectangle and subtracting the 3 units from the triangle, and then I'm going to subtract out this little triangle, which is, we found from the other page that this is 2 by 1, so I'm going to subtract out this triangle, and that's 2 times 1 divided by 2, which is 1 unit. Subtract out 1 unit, and then 21 take away 3 is 18, take away 1 is 17 centimeters squared. So with a little less work, we get the same answer. Oops. So you could look at both of those.